In this video, we're going to look at a topic called limiting reactant. There's two learning targets that basically deal with this concept. One is this first one. I can calculate the amount of product produced if the starting amounts of reactants are known. And then also, I can determine the limiting and excess reactant for any reaction. So to get into the concept of limiting reactant or limiting reagent, I have a simple kind of exercise for us to look at. Imagine you had 4 slices of bread, a full jar of peanut butter, and a full jar of jelly. Okay. Our recipe for peanut butter and jelly sandwiches is that you need 2 slices of bread, a tablespoon of peanut butter, and 1.5 teaspoons of jelly. So if we took our chemical reaction and actually did it, okay, take your 2 slices of bread, put your tablespoon of peanut butter, half teaspoon of jelly, spread it, you get one sandwich, your product. Next 2 slices of bread, do the same thing. Second product. And can we make any more? Okay, at this point, we've run out of slices of bread, so we no longer can do our chemical reaction. We have peanut butter and jelly left over. We have 2 of our reactants, but without all 3 of our reactants, the reaction can't proceed. So from these ingredients, you can make 2 products. You can't make more than that. In this case, your bread is what's called then your limiting reagent or your limiting reactant. Reagent is just a name for a chemical formula. It's a more general term for any compound, where reactant obviously would be for just the things reacting together. So bread in this case is your limiting reactant because it limits what you produce. If all of a sudden you had more bread available, this reaction would be able to continue to proceed. Peanut butter and jelly in this case then are considered your excess reactants. When the reaction stopped, these are reactants that you had left over, still available to make product with, should all of the ingredients be available again. In terms of the actual chemistry behind this, when we're dealing with 2 reactants, even if we use perfect stoichiometric amounts, where mathematically on paper it looks like they both should be used up to make product, the truth is we're not that perfect. Okay? When you weigh something on the balance, more than likely it won't be exact, and you should end up with a small amount of one reactant left over. In fact, usually we just use whatever the cheaper reactant is and put it in an excess so we don't have to deal with it. By excess, I mean we don't even measure it a lot of times. Okay? The reactant that's left over in the end that doesn't fully get used up, that's the one that we say is in excess, like peanut butter and jelly. The limiting factor, the one that runs out and thus makes the reaction stop, that's called your limiting reagent or your limiting reactant. The bread on the last slide was your limiting factor. Here's what problems look like when dealing with limiting reactants. The only difference between what you were doing and what this is that now you're given 2 numbers. So far we've just been given 1 number and we've converted from that to wherever it's asking us to go. Now we have 2 numbers. We have 2 numbers because for a limiting reactant problem, we're given information on both reactants. And we're asked how much product can be made. Well, the truth is one of these chemical compounds is going to be in excess, meaning it won't fully be used to make product, and one is limited, meaning that full amount will be converted into product. So how do you do it? Let's walk through this problem. Here's how you do limiting reactant problems. Right now, essentially, I have 2 starting amounts. I have to do 2 stoichiometry problems. Okay? This 10 grams of aluminum can make a certain amount of aluminum chloride. These 35 grams of chlorine can make a certain amount of aluminum chloride. I can't predict right now which one will run out first. Yes, I know I have less grams of aluminum, but remember that in the end for a chemical reaction, it's by number, not by mass, which means really how many moles of aluminum are in here. And then it also has to do with my recipe, because if more aluminum is made or is used per aluminum chloride, then it could run out first, or the chlorine could run out first. It really depends. So how I do limiting reactant problems is I convert both of these into the mole of your product, and I compare that final number. So How do I convert to mole? Well, you got grams here, grams to mole of chlorine to start with. The molar mass of chlorine is 70.9 grams. And then from moles of chlorine, I convert to moles of that product, which is the aluminum chloride. And the relationship of moles of aluminum chloride to moles of chlorine are your coefficients. So it's 2 to 3. Executing this stoichiometric calculation will tell me how many moles of aluminum chloride can be made from 35 grams of chlorine. I do the exact same thing to aluminum so that I can compare my numbers. So this is the molar mass of aluminum. And then I go from moles of aluminum to moles of aluminum chloride using, again, my coefficients from my chemical reaction. I fill those in. Now, if you do this on your calculator, what you're going to get is 2 amounts of moles produced from these 2 starting amounts. So doing this one, I get 0.371 moles of aluminum chloride being produced from 10 grams of aluminum. And doing this one, I get 0.329 moles of aluminum chloride being produced from this amount of chlorine. So now we have to think about what this means, okay? When I have 35.0 grams of chlorine, that can produce 0.329 moles of aluminum chloride, given this recipe. When I have 10 grams of aluminum, it can produce 0.371 moles of aluminum chloride, given this recipe. Now, if I mix these 2 amounts together and they're trying to make product, if you think about it, they're going to be reacting and they're going to make, a little bit of moles, and then they'll keep going and they'll keep going. And chlorine will get to 0.329 moles of aluminum chloride, as will aluminum, and then your chlorine will be gone. Your aluminum could make up to 0.371 moles of aluminum chloride, but it can't make that amount because the chlorine will be gone. You can't make 25 peanut butter and jelly sandwiches because you only have enough bread for 2. You only have enough chlorine for 0.329 moles of aluminum chloride. If you had more chlorine, you could add it back in. You could get up to this 0.371 moles, but you don't have it available. Chlorine then is my limiting reactant, which I usually just abbreviate LR. And aluminum is our reactant that we have in excess. Meaning, once the reaction stops, I'll have only used the amount of aluminum needed to make 0.329 moles. 10 grams makes 0.371, but I'll only make 0.329. So I'll actually have some aluminum left over in my container once the reaction's done. The final step for this problem would be to get to grams of aluminum chloride. Well, if you look at these 2 equations, we're saying this is my limiting reactant. This is what dictates how much aluminum chloride could be made. Meaning this is the equation that I need to take to grams. So for a limiting reaction problem, here are the steps that I basically just went through. Step 1 is to calculate how many moles of the product you can get from the 2 reactant numbers that are given to you. Once you get those 2 mole numbers, you have to compare them. The lowest mole number will be the amount you'll be able to be produced, and that will be based on your limiting reactant. Now, just be careful in the end that you really focus on what you're converting into. You want to convert to a place that's comparable. If you have 2 different things, you can't really compare them. Okay? If you converted to jelly and peanut butter, you're like, oh, I have enough of each. But you don't know if both of them will end up in the same one unless you compare things that are the same. Okay? So general format, gram to mole, lowest numbers of limiting reactant, take it one step further to convert to what you need it to be. So an example on the board here, again, the 0.329 is your limiting factor. Once the 35 grams of chlorine is used up, the reaction will stop. Going back to the board then, the final step would be to use the molar mass of aluminum chloride, which is 133.332 per mole, to get you to a gram amount of aluminum chloride produced by this chlorine. And if you plug this into your calculator, you should get a final answer of 43.9 grams of aluminum chloride being produced by the 35 grams of chlorine. Again, if you took the top one, 2 grams, you would find it's bigger, just like the mole amount is bigger. So this is the actual answer to the question, how many grams of product can be formed. Chlorine is your limiting reactant, aluminum is your excess reactant. In class, we will do more practice for this, and we'll also do our second component, which is the final question of how much excess reactant is used or left over once the reaction is finished. And that is sometimes another daunting problem. So go ahead and do the form and have a nice night. I'll see you guys in class.